My name is Sid Akula. Welcome to my lightning talk, building machine learning algorithms through Google Colab. First of all, going for let me explain the title. For a lot of people, like few questions, what is ML and how does it differ from artificial intelligence and how does it differ from deep learning? Those are the questions I came across as soon as I said, this is the topic I'm going through, that I'm gonna present. Before I explain that topic, let me just go through the overview of what we are going to see today. So first we'll know what is machine learning, deep learning, and artificial intelligence. These are, for a lot of people, these are interchanging terms, kind of synonyms. If you haven't worked on any machine learning models or deep learning models, then there is a lot of probability that you may interchange the terminology for that. So let's figure out what is the difference. And then let's go through how does machine learning help in our day-to-day life, and what are different other technologies that are in place to subside machine learning technology. And then we'll know how and why the Python is used for machine learning. So as a backend developer who uses Java in the backend technologies, I am fascinated with how Python is and started learning Python recently. And that's when I discovered machine learning, which is extensively used. So let's figure out why Python is used for machine learning instead of any other backend technology like Java or .NET or anything else. Then some of the important topics that we need to know before building any machine learning models is what are different neural networks and what are the key libraries that we can use to build the machine learning models. And then we'll go through the steps of building a machine learning algorithm. I know there are a lot of people who have built the machine learning models, so I'm going to just demonstrate a simple machine learning model. Don't expect too much from me. It's a very simple demonstrable model. We'll take a simple use case and see how we can build the models. And then we'll see what is Google Colab, because that's where we are going to build this simple use case machine learning model. And then we'll go through the machine learning use case where we'll demonstrate the machine learning model building on the Google Colab. So let's go in. So what is artificial intelligence and what is machine learning and deep learning? Artificial intelligence is the superset of machine learning, and machine learning is superset of deep learning. We can simply say this, I have demonstrated through some image. It's not my image for information, but it perfectly summarizes what are three different topics. So deep learning is a subset of machine learning where we'll know the deep insights of what we are going to compute. For example, it's a software that mimics the neurons of our brain. Just like what the neurons of our brain does all the functions, the deep learning concepts does analysis and figure out the structure of what a action is and performs the actions necessary for us. And similarly, machine learning, it is a concept which is used to train the computer for every task, just like us. When we are kids, we don't know to perform certain tasks, but over the years, we understand and we understood how a certain task is performed. So in the same way, In the same way, machine learning models are built based on training and the programming concepts through the training. And artificial intelligence is superset of everything. We can consider the automated cars, automated machines, and the trained machine learning models. Everything comes under artificial intelligence, just like you can see here. So there are some of the proven benefits of machine learning. So there are tons of machine learning benefits that we can use in our day-to-day life, but I have picked only a handful of them because these are the proven machine learning benefits. So rapid deployment and continuous learning is one of the prime criteria why machine learning is becoming popular nowadays and famous nowadays. For example, if there is an error in certain machine learning model, there is a probability that next time it would correct itself by more rigorous training, by providing more data sets. And so gaining the insights into the data sets that we have provided. For example, nowadays we have tons of data available from banks, all the financial institutions, media, and everywhere. And we don't know how to dig in through multiple data sets that we have available. So building models and training those models by the data sets that we have provided, we can gain insights into the data of the data sets. And all this training is done based on very less human intervention. We don't have to train it. All we have to do is provide the data sets and train the algorithms. That's how less human intervention can be performed. Less human intervention is done, and like errors are prone less. And forecast and sentiment analysis is something where machine learning is being used extensively. Nowadays, for stock markets, or even for cryptocurrency, I would say I was recently going through one of the cryptocurrency model, machine learning model, which is predicting the cycles of ups and downs just based on the historic data that we have from the last 10 years. So far, there are 3 big cycles: 2013, 2017, and 2020. So certainly there are there may be other cycles in future where the cryptocurrency, for example, Bitcoin, may go up to 200K or 150K. So based on the previous data, the machine learning models can be built so that they can forecast the future. It can be applicable for the weather forecast as well. So why is Python being used for machine learning models? After practicing the machine learning models and building few simple machine learning models, one thing I understood, though it's a negative side of like using Python for machine learning, since it's a lightning talk, I just want to say, from the beginning of machine learning models, all the community that is building the machine learning models is like relying mostly on Python because it's simple nature and the readability of code, and some other Jupyter notebook and lateral coding. There are a few things which are only applicable for Python, and only Python can be used for machine learning, that I have noted here. So readability and extensive availability of Python libraries, Jupyter notebook, and literate program. The main concepts of why Python is being used in the machine learning. I would say the machine learning community is actually forcing people to use Python. As a backend developer, that's what I felt, because all the libraries and all the data that is available for machine learning is exclusively available in Python. Different types of neural networks. So as I said, machine learning models are built based on training and understanding of different concepts. The main thing that anybody needs to understand is different types of neural networks available in Python. Because every time we build a machine learning model, we need to understand what is the neural network that is chosen to build a machine learning algorithm or machine learning model. There are 3 different types of machine learning. There are 3 different types of machine learning neural networks, which are deep neural network, convolutional neural network, and recurrent neural network. Everything has an upside and downside for using, but based on the machine learning algorithm we are going to build, the developer or the machine learning model builder needs to choose which is the neural network they need to choose for building the machine learning models. So convolutional neural network are one of the most popular neural networks that I'm going to use at this point, and most of the simple machine learning models are built because they have multiple layers. They have multiple layers which analyzes every set of data, individually, whereas deep neural network is a simple neural network. that is used based on an input, the analysis part, and the output. So deep neural network is something very basic, whereas convolutional neural network is something that we can use based if we want to scale it. For example, if we want to use 2 data sets, deep neural network is used, whereas convolutional neural network is used if there are thousands of data sets. Some of the key libraries that I have used for building machine learning models or algorithms are NumPy, Pandas, PyTorch, MATLAB, and OpenCV. These are the basic libraries that I have come across and that are really helpful. So though there are tons of other libraries, these are the prime libraries being used nowadays for building all the ML models. Sorry. So the steps of building a machine learning algorithm are identifying data, preparing data, and identifying features of the algorithm and training it, and evaluating the performance. Every step has its importance because what we can continue up to second step in machine learning models building and discontinue at that point because we may find something different. For example, if we take a use case and if we take a data set that is having 7,000 records, after preparing the data, when we are training the model, if we find it's not working, we can discontinue the process of building machine learning model. So every step is a reliable step in the machine learning model building. So when we go through building one of the machine learning model, we've definitely come across how each step is important for itself and how a step can be discontinued if we didn't see the reliability. Even though, even though during the algorithm's performance determination, there is a way to find if the algorithm's performance is 90% or 80% or 70%. It can be discontinued early on, even without algorithm's performance determination in the machine learning model building. So let's see a simple use case where I will import the libraries. Just like I said, I will import the libraries, prepare data, train the algorithm, and do the performance evaluation. So all the importing process and running process takes a bit of time. So I have built a model already, and I'm gonna share it here. So this is the Google Colab, colab.research.google.com. This is the open source service provided by Google. It is primarily kind of Python editor online, but since all the machine learning community, model building community is using Google Colab, I thought this is the best use case, best editor that I can show building the machine learning models. So like I said, I have imported the datasets directly from the Keras datasets. This is the open source datasets provider. And yeah, I have imported one of the available dataset, that is image classification is the dataset name. So it might be a bit. Yeah. Sorry.
Can you please zoom in a bit?
Oh, sorry. Yeah.
Thanks.
Yeah. Just like the Python libraries, this is the simple process where I'm importing the datasets from Keras library. Keras is the open source datasets provider. We can go to keras.com and see a lot of datasets where we'll import, where we can import from the choice of our interested dataset. I have imported something called MNest. It has 7,000 records, or sorry, I'm not sure how many records it is having, 7,000 or something, which I will use to train my machine learning model to find to do the image classification. Image classification is something sorry, first of all, before even going to this, I should explain what is the use case I'm doing. The use case I took for this demonstration is image classification, which is the data set will be having thousands of images like this. And we will be training the machine learning model to find the number inside the image. For example, if there is an image which is having U, which is like 0, machine learning model will build the machine learning model in such a way that there is a differentiation between U and 0. Sometimes we forget to complete the 0 by joining the dots, and even so stuff like that can be found through training the machine learning algorithm model. So the first step is importing the data sets, and these are the libraries that I have talked about earlier. The important libraries like NumPy and the other libraries that I have mentioned. And MATLAB is the important library that is used for visualization, that is extensively used after we train the algorithm to visualize what this algorithm has been trained. MATLAB is necessary for that. You can go to this same website, matplotlib.com, and it has all the details of how different images are used for, how different data sets are used for visualization. So X-train and Y-train, it's just like building the machine learning models by using the commands of load data is a command. All these models can be built by using the commands just like the matrices. In the bachelor's, I'm sure people might have studied the matrices concepts, and matrices concepts is perfectly applicable for the machine learning model building. We will train individual models. For example, first of all, while training the X variable of 0th place, shape is a command again. We want to see what is present in the first place of this image data set. And this is the image. Let me show by changing what is the 4th image of the data set. Importing the model, declaring the matrix, printing what we have in those models. And shape of the model, it is 28 by 28, which is the matrix size. Yeah, in the 4th image, I have a number 9. If you see here, while training, I took the 4th reference, whereas the assigned number is something different. So I have to say that X numbers associated model is Y-trained associated model. So these two are like, this is the image and this is the number that is assigned for the image. So we are saying that this image is having 9 through the data set, since that's what we have imported. So for all the 7,000 images, there will be a X-trained model and Y-trained assignment of what the image is about. Similarly, for all the 7,000 records, we take the image and we'll give the name for the image through the data set. Let me take something different and see what I have at the 6th place. So we have it as 1, I guess. Let's see. Yes. So all the blurry images, all the images are having certain numbers, and each one is assigned certain name, just like I'm saying. So I can go through the details, but it's a lot. So I'm skipping through the details and commands that we have. And the algorithm size is 28 by 28. So once we initialize the X-train and Y-train, we pass the whole array, just like this. If you see here, it's hard, since it's so small, it's hard to differentiate between what I see in this image and what we see in this algorithm. So these are all like pixels of the image. So the first step is the image, and second step is the pixelized image, where we will train the machine learning model that this image is having these many pixels, and the pixel is having these many numbers, where the individual number is populated only at certain point where the number will be present in the image. In the same way, we'll train further our machine learning algorithm, where we'll go further accurate. If you see here, it has changed. Though it's not certainly one, but as for the data sets, we are training the algorithm that this is how the one looks like. So we are increasing the accuracy and saying that at the first place, the image is having this, and image reference is this, like one. And then we are going further, where we are saying, we are passing further details of the matrix, and we are saying, make it more accurate, make our machine learning algorithm more accurate. And then we are going a step further. Here we have numbers, here we have decimals to the, I think the previous one is having decimals, but this one is not having the decimals. But what I'm trying to say is these pixels are further improvised, and we're going more in detail. So as we go through that step by step, we develop the machine learning model to understand all the data sets, and we build the machine learning model. So this is all part of the process to build the machine learning model. And when we use the model to evaluate what we have trained so far, it will give the accuracy of the image by comparing the image model and the data set provided to it, and say how accurate is our machine learning model. So here in this case, it says the machine learning model is 97% accurate, which means the probability of finding what is the number inside image for my current model, machine learning algorithm or model is 97%. The same can be, in the same way, multiple data sets can be imported, and our algorithms can be trained, and see how good is our algorithm by evaluating step by step. So this, it might be confusing, but there's a way of building the machine learning models where we'll train by passing the data sets that I have shown in the beginning. Let's go back. Yep, in conclusion, the topography of machine learning model is evolving with the improvements by contributions of development community, and the resources have increased. So I definitely think in future at certain point, when the accuracy of every machine learning model may reach up to 100%, because machine learning models have the capability of self-healing themselves. Every problem can be solved by themselves as they train and train further. These are some of the sources that I have put in here. I haven't pushed anything into Git yet, because I'm still trying to find a way where all these sources that I have developed on the Google Colab can be easily accessed from the GitHub. So please let me know if somebody wants details. I can provide offline. That's it for me. Thank you so much.